So we have to show that the second partial derivative of phi with respect to x plus second partial derivative of phi with respect to y is given by of the function, the second derivative of function f of r plus 1 over r multiplied to first derivative of function f of r, given phi is a function of r and r is x square root of x squared plus y squared. So let's begin. So here we have phi is equals to f of r, and we have r given by square root of x squared plus y squared, or simply r squared equals to x squared plus y squared. So what we'll do now, we'll take the partial derivative of our function phi with respect to x. So that means we'll also have to take the partial with respect to x of our function f of r. So when we take its partial derivative, so we'll simply get the first derivative of function f of r multiplied to partial of r with respect to x. So here we'll have to apply the chain rule. Fine. Now we'll find out the value of partial of r with respect to x using this particular expression. Right. So let's label this as equation number 1. Now from equation number 1, what we'll do, we'll take the partial with respect to x of r squared, which will be equals to partial with respect to x of x squared plus partial with respect to x of y squared. The partial of r squared with respect to x will be 2r times partial of r with respect to x equals to, so partial of x squared with respect to x will give us 2x plus partial of y squared with respect to x will be 0 because y will be treated as a constant. So this gives us partial of r with respect to x equals to x divided by r. So let's label this as number 2. So what we'll do, we'll use 2 and rewrite partial of f with respect to x as equivalent to the first derivative of function f of r multiplied to x over r. So let's label this as number 3. Now what we'll do, we will start with equation number 3 and we will take the partial derivative on both sides with respect to x. That means we will have partial with respect to x of partial of phi with respect to x. So this will be equals to partial with respect to x of f prime r times x divided by r. So let's find out the partial derivative of this given expression, and here we are going to use the quotient rule. So here we have in the denominator r squared. So in the numerator we will have r multiplied to partial with respect to x of f prime r multiplied to x minus we have f prime of r times x. So this will be multiplied to partial with respect to x of r. So this will give us r multiplied to, so here we'll have to apply the product rule because we have the product of two functions f prime of r and x. So using the product rule we have partial with respect to x of f prime of r, and this will be multiplied to x plus partial then we have f prime of r multiplied to partial of x with respect to x minus f prime r times x whole multiplied to partial of r with respect to x, but partial of r with respect to x is simply x over r, whole thing divided by r squared. So that means now we will further simplify the given expression in the numerator. So we have r multiplied to, so partial with respect to x of f prime r will become f double prime r multiplied to partial of r with respect to x. So we'll have to use the chain rule here, and we also have x multiplied to it, so x will get multiplied plus f prime r and partial of x with respect to x, that's simply equals to 1 minus we have f prime r, so this will be multiplied to, so we have x multiplied to x over r, so this will be x squared divided by r whole divided by r squared. Now we will have r multiplied to x, so we have r times x times f double prime r, so partial of r with respect to x will be x divided by r plus we have r multiplied to f prime r, so we have r multiplied to f prime r minus x squared over r times f prime r. whole thing divided by r squared. Right. Now here we have one r and one cancelling out. So that leaves us with x times x, which will be x squared times f double prime r plus r times f prime r minus x squared over r times f prime r whole divided by r squared. So we will divide each term with r squared. This will become r cubed. So this is the second partial derivative of phi with respect to x. Right. So let's label this as we have considered the equation, the last equation to be 3. So let this be equation number 4. So we'll come back to it a little while from now. So what we'll do, we will again consider our given function, which is phi equals to f of r, and the given equation that r squared is equals to x squared plus y squared. So now what we'll take partial of phi with respect to y, which will be equals to taking partial with respect to y of our function f of r, and similarly we'll also take partial with respect to y of r squared, which will be equals to partial with respect to y of x squared plus partial with respect to y of y squared. Right. So this is going to give us f prime r multiplied to partial of r with respect to y. So this is obtained as a result of applying chain rule, and we have here 2r multiplied to partial of r with respect to y equals to, so partial of x squared with respect to y will be 0 because x will be treated as a constant. Now that leaves us with 2y, which is partial of y squared with respect to y. So that means we have partial of r with respect to y, which will be equals to y divided by r. So let's label this as equation number 5. Now we can use number 5 and replace in place of partial of r with respect to y, such that the partial of phi with respect to y will then be equals to y times f prime of r divided by r. So we'll label this as equation number 6. So let's start with equation number 6, and then we take the partial derivative with respect to y on both sides. So we have partial of phi with respect to y, which will be equals to partial with respect to y of y times f prime of r divided by r, which gives us the second partial derivative of phi with respect to y. So this will be equals to, so here we will have to apply the quotient rule. So that means we have our denominator given by r squared. In the numerator we have r multiplied to partial with respect to y of y times f prime of r minus y times f prime of r. This will be multiplied to partial with respect to y of r. This will give us, we have r multiplied to, so here we'll use the product rule. So that gives us partial of y with respect to y multiplied to f prime of r plus y times partial with respect to y of f prime r minus, we have y times f prime of r multiplied to the partial of r with respect to y. We can replace this with y divided by r, whole thing divided by r squared. So that gives us r multiplied to, so partial of y with respect to y, so that will be 1. So this will get multiplied to f prime r plus y times, so we have to take partial of f prime r with respect to y. So this will give us f double prime r, or multiplied to partial of r with respect to y minus, so we have y squared divided by r times f prime r, whole thing divided by r squared. So this gives us r times, so we'll multiply r with the two terms within the parentheses, so we have r times f prime of r plus r times y times f double prime r multiply to partial of r with respect to r, that will get replaced with y divided by r minus y squared over r times f prime r whole thing divided by r squared. That is, r and r gets cancelled away, and we can now express the second partial derivative of phi with respect to y as 1 over r times f prime of r plus, so here we have y times y, which will be y squared. So we have y squared divided by r squared times f double prime r minus y squared over r cubed multiplied to f prime r. So let's label this as equation number 6. So what we'll do, we will add equation number 4 and equation number 6 to each other. So let's do that. So we have second partial derivative of phi with respect to x added to second partial derivative of phi with respect to y. Right. So we'll combine the first term and the second term of equation number 6. So we have 1 over r squared multiplied to f double prime r. This will be multiplied to x squared plus y squared. Plus, so we'll consider the second term in equation number 4 and add it to the second term in equation number 6. So they are the same term. So we have 2 over r multiplied to f prime of r. And finally, we add the third term of both equation 4 and 6. So here we can take 1 over r cube times f prime of r. That this will get multiplied to x squared plus y squared. Now we know that x squared plus y squared, so this value is equals to r squared. So that means our expression will then become, so here this is r squared, so we'll have f double prime r. So this r squared term and this x squared plus y squared goes away. So here we have r squared and 1r from the denominator goes away. So that leaves us with 2 over r times f prime r minus 1 over r times f prime r. So we can combine the second term and the third term, and that's going to give us f double prime r plus 1 over r times f prime r. So hence we have successfully shown that the second partial derivative of phi with respect to x plus the second partial derivative of phi with respect to y, so this is given by f double prime r plus 1 over r times f prime of r. Hence proof. This is what we were asked to show.